Global Azure Data and AI Fest. It's a virtual artificial intelligence and machine learning conference. It is a free conference and community driven. And the organizers of this conference is Tim and myself. Tim, would you like to introduce yourself?
Hey, everybody. I'm Tim McAliley. I'm a senior customer engineer for Microsoft. I live in the DC area. I work with Prashant on a lot of community events, and I run primarily the Northern Virginia Data Platform User Group, and I work with Prashant to administer some AI and ML user groups. So, good morning, and thanks for attending.
All right, thanks, Tim. Yeah, as Tim mentioned, we are both local to the Washington, D.C. area. I currently work at Witham. Witham is an advisory tax and accounting firm based in United States. And I currently work as senior solution architect where I use variety of the products and features in Microsoft ecosystem. I'm also a Microsoft MVP in AI category. And MVPs typically don't work from Microsoft. It's just additional recognition that Microsoft gives out to few people. So if you are, thanks for joining us today. And if you would like to participate in the future events, do check us out on azurecloudevents.com. And we also periodically post the latest and greatest updates on our meetup pages. And we have four meetups. Sorry, one is on Azure and AI and machine learning. Second one is on SQL and big data. And third one is again the extension of our AI and ML user group.
Yeah, for the Azure, oh, can you go back to the other, for the Azure Cloud Events .com? We're working on that right now. So that will, or in the coming weeks, that'll actually be the central place where we'll direct you.
Right.
You'll be able to hop off from that link onto the meetup groups or our conferences and events and our YouTube page.
Thanks, Tim. And this is going to be the agenda. So we started the event right at 10 a.m. Eastern time. And then at 10:15 a.m., we will have a keynote from Frank Lavigne. Many of you have already heard about him or have seen him speaking. Frank is a fantastic speaker. Until recently, he was working from Microsoft, and now he has joined AI startup. And looks like Frank has joined us.
Yay, Frank.
And then, hey, Frank. And at 11 o'clock, we will have a talk from John Topitza on Azure Machine Learning. Then at noon, we will have a talk from Veronica on speech services. At 1 p.m., we'll have a talk on natural language with Kiran. And the last session of the day, I will be talking about the cognitive services and AI in general for everyone. And then we will wrap around 3 p.m. All the sessions will be recorded and we will be posting those sessions later on our YouTube channel. It may take maybe 1 or 2 weeks for us to process all the videos and post that. And once that is done, we will be sending a blast email to all the attendees so you know where to go and where to find those recorded sessions.
Yeah. Hey, actually, I'll be in the background during the conference. So as sessions wrap up, I'll be able to process the video. So we should have video for all these sessions up by this evening. And that's at youtube.com/Azure Cloud Events.
Mhm. And since we are using Microsoft Teams conference, like Teams for this conference, please feel free to ask questions using the chat window. Tim and I will be periodically monitoring the chat window. You can also use the feature raise your hand in Teams, or you can also unmute yourself and ask the question. And regarding the questions, it all depends on the speakers, whether they would like to have the questions in the beginning of the session, sorry, toward in the middle, towards the end, or throughout the session. So speakers will typically tell you when exactly you can ask questions, but most of the speakers are fine if you ask more and more questions because that makes all the sessions interactive. And also it also helps other people as well to explore other things that they may not have thought about. So this is a quick lineup for the speakers. These are our LinkedIn profile links, and we will be posting this in the chat window as well. So feel free to connect with us on LinkedIn. We're happy to stay in touch. And with that, we are happy to pass over the control to Frank. and Frank will be doing a keynote today. So Frank, all yours. I will stop sharing now, and let us know whenever you are ready. And Tim, you can stop recording.
Well, I'm recording Frank's session.
Okay, all right, perfect.
Yeah, so I'm just going to let it roll. One thing we
Awesome.
did,
Can you hear me?
one thing,
Yes.
Frank, one thing, Frank.
Yeah.
Just where there's a tie-in for the other four sessions, for John's session, for Veronica's sessions, for Kieran's session, and for Prashant's session. There is an MS Learn tie-in into each of these
Right.
sessions with links to MS Learn courses. The links are in the RSVPs on Meetup and in Eventbrite. So do take a look at that. This is a great takeaway from the session because you can hear what these speakers are talking about, but you can also interact with that information repeatedly for free off of MS Learn. But thank you, Frank. I'll shut my mouth.
Oh, no problem. Tim, Prashant, it's always a pleasure.
Oh yeah.
Uh, I do miss working at Microsoft. So as they mentioned, I did change companies recently. I joined a startup called Electrify, and we'll talk about them in a little bit. But I swear that this talk is not going to be a commercial for Electrify. This is really kind of the trends and future of AI, and then maybe you'll understand my rationale for leaving Microsoft and handing in my blue badge. I'm a principal solutions architect. If you've not heard me speak before, welcome. Thank you. My email addresses are there. I have two podcasts and a blog. Franksworld.com has been online in some form or the other since 1995. Although due to a glitch in the matrix, all the data since prior to 2017 was lost into the ether. Uh, I have a podcast called Data Driven, which I run with my good friend Andy Leonard, and another podcast on quantum computing, and we'll talk about that. That little QR code there is a link to my LinkedIn profile. So hopefully you'll be able to connect with me later. But ultimately, today is about kind of what the future and what does the future of AI look like. Well, that's a question when I was asked to kind of talk and deliver a keynote. What does the future look like? Because certainly we have these visions of what the future will look like: driverless cars, computers, and AI taking jobs away, all of the apocalyptic type stuff. And granted, after last year, I understand why people's attitude has gotten pessimistic. But the best way to predict the future is to create it. And I hope that this talk, even though there's a typo in Peter Drucker's name, um, will inspire you to kind of think differently or think bigger and better about what the possibilities are for the future. And but how do you predict the future, right? There's really no way of knowing the future, because if I could predict the future, I would be working the tables in Vegas every day. Well, maybe until I get bored and then I'd move to an island somewhere. But ultimately, here's kind of the six things that we should keep an eye on. First off, riches are in the niches. That's another quote from Pat Flynn, who is often quoted by one of my favorite podcasters in the world, is John Lee Dumas and Entrepreneurs on Fire. Highly recommend that podcast. Next thing is IoT and the edge. IoT is the hotness, right? And everything's getting connected to the internet. But to me, as a data scientist, IoT is just a funnel for data, right? I don't, yeah, it's nice and all. I can turn my lights on and see cameras in my house, or check on the HVAC from a distance. But the real thing, the real value prop there, is the data that's going to collect and the type of work I can do off that in the future. Next thing is containerization. Virtualization really changed the game, in the early 2010s. And I think that containerization is totally changing the game of how applications are developed, written, and how even AI models are deployed. Next up is automated ML. Now, this was something that on a previous stage, way back in the before time, when we were meeting in person, someone asked a question: what do I think of auto ML? And I kind of poo-pooed it, that it was just going to be kind of well, not really relevant. It's just kind of all hype, and it's not going to take AI or ML jobs away. And then I don't know if you ever seen World War Z, but there's a concept that they introduced in the movie that there's a government agency somewhere that anytime they hear something that's just so preposterous and so ridiculous that they go and they actually will look at it because it's so preposterous and ridiculous, and they go and try to prove it right. I know I'm not explaining it right, but it's a good movie if you haven't seen it. So I kind of, after having written a Silverlight book and being a Windows Phone developer evangelist, I realized that maybe I can't always predict the future. So maybe, even though I think that may be ridiculous, let me take a look at it. And I had my aha moment when I was just able to, in 15 minutes, solve a data science problem that I had worked on for my certifications. It took me about a week and a half. The AI was able to do in about 20 minutes. And altogether, to prep the data and shape the data to make it work through the automated ML was a 40-minute experience. That was my aha moment. So I'll talk more about that in detail later. Secondly, data. Data is the new oil, and AI is the new electricity. But you can't have one without the other, although I suppose you can ruin my analogy with wind, solar, and natural gas. But stick with me. I'll explain that a little more in detail, what I mean by that. And finally, quantum computing. Quantum computing, I had my aha moment about quantum computing when, again, in the before time, at the last Microsoft research kind of conference that they throw for employees. And they were talking about kind of the future of what compute looks like. And they kind of talked about quantum computing and what that means. So these, some of these are buzzwords, some of these are not buzzwords. But ultimately, let's start here. The riches are in the niches, and making big impact in small markets. Apparently, he's written a number of books on this. So, but I've only heard this quoted by John Lee Dumas like 1 billion times. And I think, that word small tends to turn off a lot of people, because why would I want to be in a small market where if it's too small, I won't be able to do anything meaningful. And John Lee Dumas will explain this at least once or twice a week in his podcast. But ultimately, if you doubt that anything is too small to have an impact, I would encourage you to think about, if you're too small to have an impact, look at what this tiny, stupid virus did to the world. We certainly do have an impact. So, and this is what really made me want to join Electrify, because they basically took the service model that Microsoft has, right, with cognitive services, right? I go and I can get a cognitive service to do text analytics. I get a text, there's form recognizer, computer vision, all text to speech, all of this stuff that's out there that Microsoft produces. Now, the true opportunity for Microsoft, that makes sense, right? Because you want to solve the world's problems. But for a smaller company like Electrify, what we really kind of realized is like, well, what if we solve the niche problems, right? What if we solved, for telecom companies, right? Customer service, figure out call center reduction, churn mitigation. These are big business problems that virtually every subscription business has faced in some way or the other, whether it's Netflix, whether it's T-Mobile, Sprint. Sprint doesn't exist anymore, or Verizon or AT&T. All of these problems. And if you look at this list, it's not just limited to telecom, right? There's contract AI. Everybody has to deal with contracts, right? Contracts, I guess, arguably are a type of form, which Form Recognizer can handle, but it's not, Form Recognizer is not built to do clause extraction or finding indemnification clauses, right? Or governing law, right? All of these types of things are really kind of niche problems, very specific problems. When we work with banking, mortgage, HR, public service in terms of healthcare, right? We're in the process of making the Pulmo AI, where it can actually identify apparently the new strain of COVID Delta can be quickly ID'd through an X-ray. And we've developed an AI that can kind of give you a pretty good confidence, like 80, 90%, to find that. So all of these niche problems, whether all of these companies deal with this, right? We have a very interesting thing in terms of animal welfare. Again, I'm not turning this into a commercial for Electrify, but I'm just saying that the overall kind of generic type of approach of boiling the ocean, that's you need a big pot to boil the ocean, and a company like Microsoft certainly has a big pot to do that. But in terms of these niche problems, right? Whether you're trying to upsell, cross-sell, churn mitigation, all of these types of things, that's really where I think the opportunity is, and that's the opportunity that brought me to Electrify. Another interesting tidbit is that the worldwide market in computer vision is expected to reach 51.3 billion in just 5 years from now. And that's a continual annual growth rate of 26%. That's not too shabby. That's nothing to sneeze at. So I think that the real task, and if you kind of look around now and you see what the job market looks like, it's not enough to be just a data scientist, right? Obviously that helps. Or an AI engineer, ML engineer, whatever the hip term is this week. You have to have some kind of experience in NLP, natural language processing, or computer vision, or conversational AI. That's another one that I'm seeing kind of a niche form. Obviously, that's some flavor of natural language processing. But I think just like you saw with web development, we're seeing a lot of these trends where there's going to be specializations coming. And that's when I said the riches are in the niches in that regard. All right, next up is the edge, or IoT and the edge, right? Everybody knows what IoT is, right? It's those smart devices. But there's this concept that is kind of tied to that, that you don't hear, or you're starting to hear more of, and that's the edge. But first, a joke. The S in IoT is for security. So I will assume everybody's laughing, but ultimately, one of the opportunities or problems or opportunities in this space is not just kind of the edge, but also security in IoT. And a lot of this is going to evolve around things like physical gateways, securing self-driving cars. Yeah, self-driving cars are going to be safer than humans driving. However, if those get hacked and you have an accident, there's definitely some room for bad actors to play. And if you think I'm crazy or I'm being wearing a tinfoil hat, I ask you to just think back to about 6 weeks ago when everybody was lining up at the gas station, right? Ultimately, somebody connected something to the internet without really thinking about it. And there we were. So security is definitely, I was trying to think of, making this focused on data, but I mean security and AI and IoT. I think IoT is lacking security in a big way, and I think that is going to be a growth market. But I mean, the edge is basically the idea that, let's just say I had a self-driving car, right? And we had this magical, wonderful cloud service that was up here, and that's my attempt at drawing a cloud. So if I try to take a picture of what's in front of me in the car, right? Say there's a person here. And if this person, I'm driving at a good clip, say 60 miles an hour, and the car is going to send a question out to send its data packets of what it sees up to a cloud service that says, hey, should I put the brake on? Should I swerve? What should I do? No matter how fast 5G or the carriers will tell you 5G is, that round trip is going to take milliseconds. And if you're going fast enough, the ground situation has changed radically enough that by the time the answer comes back, the answer is useless, right? So what the idea of edge is that you would have a little something that probably looks like this inside of here, so that the decision's actually made here on the device. And now you're talking about billionths of a second as opposed to milliseconds or even seconds, right? If there's, you think about the amount of data that a self-driving car would produce. Some people say 4 terabytes a day per car. And if you've ever had the privilege of being stuck on 495, you know that there's a lot of cars on the road at the same time. So you can imagine what that network congestion would look like. So immediately by moving that decision to device, you remove that as a variable. And I also want to think about this kind of in a larger picture, right? So what are the waves of innovation here, right? So cloud basically means that I have unlimited compute I have the ability to, scale up. When I was at BarnesandNoble.com, right? So I was the first webmaster at Barnes and Noble. For us to even sell the first book, it took us. I mean, it took a lot of money, right? We had to buy a server rack, right? We had to buy this, and we had to guess for, well, how many people we think will show up? Well, we think this way. So we had to build to the maximum. You don't need to do that with the cloud. If I wanted to start a bookstore today, I mean, I could probably do that for a 5-figure sum to get that started. Whether or not that's a good idea, I'll leave that to your imagination. But if I wanted to start something like that, I mean, I could probably get away with a 5-figure amount, and probably realistically, in today's world, most of that's going to be spent on Facebook, Instagram, and YouTube ads. Realistically, so IoT, again, I think this is really what it is, right? It's really about harnessing the signals from sensors and managed centrally by the cloud. So before I rejoined Microsoft, I worked at Wintellect, and we were working with a startup, and this was cool. They worked with MMA, and they basically put sensors in the in the boxing gloves, so they would know the pitch, duration, and impact um, of the punches and things like that. So mostly that was not so much intended for the fights per se. That was so the coaches can kind of estimate how well the training was going. So they insisted, and this is a few years ago, no, everything had to be on premise. They were going to take all the sensors from these devices and put it on premise. Now think about that. I like to use the analogy of, and I'm not going to really be able to draw it well, but let's pretend this is an ant, one of those nasty little ants that bite you, right? And here's the sharp teeth. One of those bites is not going to kill you, but times 10,000, right, per second times time, that is going to be an impact. Now you're like, Frank, why are you talking about bugs? You know, cicadas in the Virginia, DC area have finally gone away. Why are you reminding me of bugs? Well, here's why. Because each one of these little sensors I'm going to attempt to draw a boxing glove, right? That looks more like a dinosaur, but work with me here. So pretend this is the sensor, right? It's sending out, I think we estimated about, I think it was like 64 kb per second is what the sensor was pushing out, right? Now, times 2, because you're going to have a sensor in each hand, times number of fighters, you could quickly see that this modest little thing, if that product took off and they were going to make it a consumer thing and make it more reliable, clearly they were going to need a big pipe into their data, their on-prem data center, which they didn't have the money to realistically do. And they decided the cloud would be the best place for that because the cloud can scale. Now, do you pay for that scaling? Yeah, you do, but you only pay for what you use. So you can price that into your product. And ultimately, another thing that they were thinking was that they were going to have some kind of thing that would be, ringside, right? So imagine this is a boxing ring or an MMA ring. Yes, I know MMA rings are octagons, but I didn't want to torture you with my drawing. But ultimately, they were thinking about having some kind of device here for when they were going to put this onto like TV, is that you'd have the two boxers. And each one would have it would basically go to here, and then some of that data would be scrubbed and then kind of broadcast over the internet for kind of a premium experience. So that, for all sorts of things. But ultimately, it's the idea that you can take all of this data at every stage here. IoT is really just collecting data. Edge is just basically kind of filtering the data and managing it and feeding it. But ultimately, the end game here is AI, right? Building out these predictive models, right? When this happens, well, when this part breaks on the elevator, then the chances are that there's going to be a massive elevator failure. Why don't you just get that ahead of time, right? This is critically important for the manufacturing space when the manufacturing floor shuts down. I mean, it could cost millions of dollars per hour in lost revenue. Next thing I want to mention is containerization. Containers have really changed the nature of what it means to be a application developer, right? It used to be that you would have way back early in my career, I would, we would have to price and price up a server. And back in the days of DLL hell, application X would not want to sit on the same server as application Y. So we'd have to buy another server, requisition another server, and all the mess that entailed, just to run this machine. So even though the machine, multiple apps were running on this machine, and it was way below capacity, we still had to buy more hardware. Virtualization really took the server world by storm because you didn't have to worry about that anymore. Every application could get its own virtual server, and you didn't have to worry about that DLL hell or the fighting across applications in the same way. Now, virtualization kind of meant that you had to every virtual machine needed to have resources and spend cycles just supporting the base OS. Containerization really kind of removed that. So now when I ship an application, I just ship a container, and I can deploy that anywhere on Kubernetes, on Docker, and on Azure. Is it AKS, Azure Kubernetes Service? And I can orchestrate these machines as these applications as if they were running on their own machines. And immediately, it makes it more portable, right? I can run a Docker container on my desktop, on my in the cloud. I can run it anywhere. One of the big things for us at Electrify is protecting our IP, so you can actually secure and encrypt what a container contents are, so that basically our models can be a black box, right? So no one can hack into it. That's a big deal for us. It's also multi-cloud, right? I know this is an Azure event, so I won't mention any other cloud, but let's pretend that that other clouds exist. But realistically, even Microsoft is doing that. If you've heard of Arc, Azure Arc, the idea that you can orchestrate your workloads across, Azure, across on-prem, across, AWS or anywhere else, that the future is multi-cloud. It's, if you're a large enterprise, yeah, you may want to favor one cloud or the other, but just in the interest of redundancy and extreme disaster recovery, it's, if I were a CIO of a large kind of company like that, I definitely want to have that in my back pocket, the ability that, AWS had an outage not that long ago. And, if I totally relied on them, I would be out of business. It's also microservices. A container seem to be custom made for microservices. And if you're not familiar with microservices as a concept, basically, if you have a web page and you were selling stuff, you'd have one service for, kind of rendering the basic product information, and you'd have another one to pull another service to have the reviews, and then you'd have another service to have the customers also bought. That's why if you're shopping on a very famous, well, I already said Amazon. So if you're shopping on Amazon, you'll notice sometimes the stuff will load at different cadences and speeds. That's apparently what's going on behind the scenes. Now, how does this apply to AI? Well, this is exactly our business model at Electrify, right? So we work with partner organizations, and if you're interested in being a partner, feel free to hit me up. But basically, customer has data sources. A partner will do all the ETL. We define, based on the model that's given there, we'll define what fields we need from these different types of systems. And then we do all the AI work and kind of take our pre-trained models, kind of train it, a little bit of custom work. And then what we supply out is a Docker container, right? We don't build apps. We don't build reports. We don't build UI. But you can use it, right? This essentially becomes like a cognitive service. Now, you can get the cognitive services that I mentioned also available as a container if you ask nicely enough and they bless you with that exception. But that's our business model, right? So this Docker container can run on Azure, it can run on AWS, it can run on-prem, it can run on an edge device. It doesn't really matter where it runs. And that's the key. So I think that this is kind of the future, right? So data science team, they build out the AI, they build out the models. Okay, well, now what, right? And you see that even in Azure ML, the deployment is basically you pick what your AKS cluster is going to be. That's ultimately kind of the I think the vision and what's making that possible. So next up, I talked about this a little bit in depth before, but automated ML. Yeah, I think that automated ML is definitely going to be a big part of the future in this space. Now, on some level, is it going to take away data science jobs? I mean, maybe. But one of the things I've seen both in Microsoft and outside of Microsoft is the common theme is that if you have one data scientist, or you have a team of say 200 data scientists at any large company, what they really need is they need 600 data scientists, right? These folks are overworked and overloaded. In fact, one of my favorite customers when I was at Microsoft was a utility company, and they had a backlog of work that was probably 2 years long. They had a team of about 12 people, but there was somebody again in the corner office had to have this problem sorted out right away. It was a customer and their propensity to not pay. It was that type of thing. So before I heard of Electrify. So I basically said, well, why don't you just get the data, show me the data that you have, and they had basically a big dump from an old IBM mainframe of a CSV file, and I was like, all right. So what are you trying to predict here, right? And they were basically trying to do a prediction problem of, I have all my customer data here, right? And then are they going to pay or not, right? So that was yes, no. Data scientists in the crowd know that that's my label, and this is a binary classification problem, which is super easy to do in Azure ML. You basically go, you upload the data, you tell it what you want to look for, what type of problem it is, and then you run it. And I think this was going back like 40, 50 years or something like that. It was like a 4 gig CSV file. And they said, we just don't have time to work on this. Is there anything you can do? And I'm like, actually, why don't you try automated ML? And I was like, and then realistically, they're like, well, we don't know. I'm like, what's the risk here? I mean, really? I mean, if you get most it's going to cost you, it's not going to cost you $100, right? And you know what? You're not putting a lot of time into it. All of the, so I walked them through, and basically I said, now go home or do other work because the cloud is chewing on this, and tell me what happens. So they had the model next morning was ready, right? And they were able to deliver a product that had 93% accuracy. Now, could a in-person data scientist do better? Yeah, they probably could, but they're not going to do it in 12 hours. you know and that's also asynchronous, right? So I could kick that off, I can go do other work, and if it's not done at night, I go home, I watch TV, I watch Netflix, I watch The Expanse or Game of Thrones, and it's done for me, right? The machine is working on it. So I think that solves kind of the shortage problem, but I probably won't take away data science jobs, maybe. But I mean, I wouldn't lose sleep over losing your job to an automated ML solution, because I think that there's just such a shortage of this. Which gets me to my next point. If you really want job security, data engineering, right? It's all about the data. Data engineering is such an underappreciated skill, but it's basically how AI works, right? Without data, there is no AI to create. So I'm going to go, and it's not I guess, a true kind of Frank Lavigne presentation until I break out the whiteboard. So I used to work at the Microsoft Technology Center in Reston, and we love the whiteboard. So basically, here's kind of the business problem here. Let me pull out my fancy graphics while I do that. But are there any questions at this point while I pull out some graphics? All right. I will assume that there are no questions. All right. So basically, what am I talking about here? Well, when I was on vacation a few years ago, we went to this place, and it basically called gem mining. So if you ever go to any kind of mountain community or where there's history of mining, they always offer this thing called gem mining. And my first thought was like, what are they talking about? Gem mining? My kids saw it, they wanted to do it. And I'm like, I don't know, because I'm thinking that you got to get hard hats, pickaxes, all this crazy stuff. But you didn't. Turns out what you do is you buy a bucket, and this bucket is filled with dirt, with rocks in it. And basically, what you do is they have an artificial flume. So you're like one of those gold panners in the Old West, And then what you do is you basically hope to get rocks, right? And when the rocks, you basically get rid of the dirt, right? So you clean up the dirt and you get the rocks. Then what you do is you take it to, most of the better places will have a gemologist on staff, and the gemologist will look at the rock and tell you, hey, you have something that would look really good. And what they'll do is you have a good gem, right? So one year my kid found a 85 carat emerald, and another year he found a 40 some odd carat amethyst. And so what they'll do is that they'll say, well, for an additional fee, they will go and cut that gem into something very beautiful. And of course, for another extra fee, they'll mount said gem onto a ring or necklace. This is my attempt at drawing a necklace, or earrings. I'm not going to even try to draw an earring. So as I'm doing this, as I'm sitting there in the flume, getting all muddy and dirty and trying to keep the kids from jumping in the flume and splashing on each other, I realized this feels a lot like work. And I don't mean like it's actual work or labor. It reminds me of my job, right? So if you think about it, this is the raw data we all have to deal with, right? And then this process here of getting rid of separating the signal from the noise, that's data engineering, right? And then this here, there's another step here that I didn't mention, is that if you get like a geode or something that looks really cool, you see crystals on people's desks, you don't have to do anything with it because it's perfect right there, right? So in that sense, I think of that as kind of BI, right? And then these folks here that do this evaluation, these are the data scientists, right? Because they're the ones that tell you, oh, you got a good nugget here. Let's explore this further, right? And then what's this? This is your model, right? So you start with the raw data, you clean it up. If you have an interesting nugget, you can throw that nugget on a dashboard, and it's self-explanatory. I have a couple of them on my desk, and they don't need any extra work because they're cool as they are. But if you want to kind of get the gem out of that, well, that's basically what the data scientists and AI engineers do. So then what's this? This is your deployment, right? So this basically is kind of, and if you notice, a big chunk of this is data engineering. I dealt with a lot of customers that they just don't have their data in the right format or the right place or the right anything, right? And this has nothing to do with how well organized or not organized I said organization so many times, how well the company has their data estate kind of in order or not. Most don't. But the algorithms that you feed this through, the data through to come up with the AI and do all this research, they're very picky eaters, right? So you have to kind of do this work anyway. So I would say is that data engineering is such an underappreciated skill right now, and there's such a shortage of those folks because most of the data engineers in the world are still operating at thinking like they're DBAs, right? And thinking about the DBA world. It's not the DBA world anymore, right? I don't need to page somebody in the middle of the night to swap out a hard drive, right? In my data center, right? Because it's the cloud. I don't have to worry about that. Microsoft worries about that. So I would say is that data engineering, and I'm seeing this constantly in my current job. I saw it a lot in my previous job at Microsoft. I'm seeing it a lot more now too, because these organizations, they have data. Or here's a great example. And I swear it's not a commercial for the podcast, but if you go listen to a recent episode I recorded with another MTC architect, Dave Wenzel, where he was talking about you don't need a data warehouse. He's talking about the future of data warehousing, right? Which is going to look an awful lot like a data lake. Now, I know that's a very controversial topic, and we hashed it out with him over about an hour and 15 minutes. But the short of it is that the future of data warehousing is going to look different. Because what's happening now, one customer I'm dealing with now, they are an insurance company buying another insurance company, right? They took their data estate very seriously and very organized. The firm they're buying, not so much. So what they're talking about doing, instead of deleting or destroying their data lake, I mean, their data warehouse, because their data warehouse is actually very orderly and very perfectly designed. The many folks would be proud to have that as their data thing. The other folks don't. So what they're actually doing is they're going from a data warehouse to kind of a lake house type architecture, where instead of doing perfecting everything, they're just going to leave everything in the mess that it's there, and then basically kind of bring order out of the chaos, as opposed to at runtime, as opposed to doing that all up front. So somebody went off mute, so I'm assuming there might be a question. No? All right. So next thing, and I will say this from a personal growth development standpoint, when I joined the MTC a little over a year ago, actually way over a year ago, I was an AI guy, right? I was an AI engineer, right? That knew some data engineering things. Because when I worked with Tim, when I was on a project with Tim, I'd be like, Tim would be like, all right, you do the AI stuff, I'll take care of the data stuff, right? That was not my wheelhouse. So when I was the data and AI architect at the rest of MTC, I skilled up. You can look at my LinkedIn profile, how many courses I took, right? So for me, for my own personal career growth, now I consider myself probably maybe 60-40, not quite 50-50. I still have AI in my heart, but now I can play a good game in the data engineering space. And for me, that definitely gives you an advantage in the career market, because a lot of these data science folks, they don't care. They just give me the data. I don't care how you get it. I don't want to touch the dirt. They're like the gemologist, right? In that story. They don't want to touch the dirt. They don't want to get their hands dirty. They just want to get the rocks that have been all rinsed and cleaned. Yeah, reality doesn't work that way. So question from Suzanne. What's the best way to start in data science world? What certification is required for entry level? So, I mean, there's a number of certification programs now. Unfortunately, the one that was my favorite is no longer. It was the team up that Microsoft did with edX. That's the one I took. I thought that curriculum was fantastic. However, now Microsoft has their Learn platform, which I haven't taken a lot of their data science classes there. I have taken their quantum stuff there and some of their Docker container stuff. That's fantastic. I don't know what certifications you would get out of that, but I do know it does prepare you for the data science and data engineering certifications. So, I mean, now let's dial it back, right? Honestly, 80% of data science is statistics. 80% is statistics. The remaining 20% is split between calculus and just knowing your way around SQL and kind of just for different data structures. That's it. There's no magic. There's no hocus pocus. But if you're not already comfortable in math, get comfortable in math. Because I was the kid that hated math in school, and it's only since I kind of retook statistics as an adult that I kind of fell in love with math. And that sounds really nerdy and pathetic. Speaking of math, this is the future, and this is probably I would say quantum computing is probably 80% matrix maths or linear algebra, and 20% everything else. Quantum computing is going to change the world, absolutely. Now here's the question: I don't know if it's going to change the world in 5 years, 10 years, or longer. But there is something very interesting here in this notion of quantum emulation. Now, a lot of folks, when they hear that, well, why would I want to emulate a quantum computer when I can get a real one? All right, that is true. So there are some problems that we just can't solve right now. These classically intractable problems, right? Simulating what medicines would do or molecules would do. How plants get nitrogen from the atmosphere, right? A full third of the energy in this world is used to produce fertilizer, right? That basically does the same thing that whatever seed you have, the grass in your yard or the trees, every plant can basically do on its own I see your question. I will get to that. Every plant can basically pull in nitrogen from the air to feed itself. What we as humans do to feed our growing populations and power our agriculture is we have to do all sorts of chemistry and magic to basically produce nitrogen to put in the soil. So to get better crop yields. I'm not a farmer, but I did start college as a chemical engineer. So basically, we don't know exactly how plants do it. We don't know how little seeds do it, right? And turns out that simulating molecular chemical reactions takes a lot of computing power, right? To the point where this is a little over dramatic, but age of the universe, right? But I mean, there are problems that right now, if they were done on classical computers with classical algorithms, would take about 10,000 years. To put that in perspective, at humans 10,000 years ago started agriculture. So 10,000 years from now is how long it would take to solve some of these problems. Yeah, but Frank, I can get myself a Xeon or Core i9 and do this faster. Yeah, you could do it a little faster, but not at the scale that you need, right? It's kind of like walking versus driving. Like you can walk 100 miles. You could drive 100 miles, right? One's going to be faster than the other, no matter how fast you can run. So what quantum computing can do is kind of solve these problems in a way that the whole talk on how quantum computing works is way outside the scope of this talk. But ultimately, it's the idea of solving these problems faster in a way that takes advantage of kind of the quantum state of subatomic particles, right? Way outside the scope of this talk. Now you're probably thinking, Frank, I don't care about simulating stuff. I just want to train my ML models faster. I want to find the global minimum. Well, turns out, turns out that that is one of the things that quantum computing can do exceedingly well and exceedingly fast. So this is from a study that Microsoft did. So of course it's map of Seattle, and what they're doing is they're calculating kind of the optimum routes here. Turns out that quantum computers are really good, or quantum algorithms are really good at solving the optimization problems. But here's kind of the trick, and this is the thing that blew my mind when I heard it, right? So classical computer would take 10,000 years to solve this problem, right? A true, real quantum computer, an actual honest-to-goodness, qubits on down quantum computer would take 100 seconds or so, right? This project here took 10 months. And you're like, Frank, 10 months is nowhere near the scale of 10,000 years or 100 seconds. What's going on? That's because they use conventional hardware which stuff you can buy today, but they use quantum algorithms. Or another way, they simulated a quantum computer on conventional hardware. Now, how does that work? Again, way outside the scope of this, but let's think about it this way. Say you have a leak in your roof, right? Actually, I have a leaky pipe in the other room, and apparently it's really hard to get a plumber. But let's pretend I go to the first. If I want to do it myself, it would take 10,000 years. Let's be ridiculous here, right? I was like, all right. So I go to the first vendor and I say, hey, how quick can you do it? And Quantum Plumbing says, oh, we can do that I could do that in 15, 20 seconds. Not a big deal. All right, when can you start? Oh, in about 5, 10, maybe 20 years from now. Okay. Go to my third contractor, right? I'll call it Conventional Plumbing. How long will it take you to do? Oh, it'll take me like a month or two. Oh, well, that's not good, but when can you start? No, I can start today. Right? That's kind of the business value. The business value here is that you get the acceleration of 10 months over 10,000 years, which is still a pretty good leap in order of magnitude. But you also get kind of the ability to start today. And that gets me to my next question. It turns out that there's a lot of problems we have with actually making an actual quantum computer. Now, you've probably all seen the pictures of the thing that looks like a chandelier that's cooled to look, near absolute zero. There's been a lot of innovations in this just in the last few months, but But ultimately, we are still talking about a time frame of 5 to 10 years or more, right? I mean, this thing here is basically saying this is the algorithm that will break kind of conventional encryption, which is everyone freaking out about. Depending on who you believe and how optimistic you are, we're either going to hit that in the next couple of years or in the next couple of decades. There's a lot of work being done in this space right now. But I think that, speaking to this is that knowing the algorithms and how to program and things like Q# and Qiskit and kind of understanding the basics, I think getting started in that today, you will be ready. When the recruiter 5-10 years from now says, "Hey, do you have 5-10 years of experience in quantum computing?" You can say, "Yes, in fact, I do." So thank you, and I will see you in the future. That's all I got. Hopefully that you found this enlightening and an interesting presentation. You can scan that QR code, but those are all the URLs. If you want to know more about what's going on in Electrify, go to electrify.net. Tell them Frank sent you. There's my blog, franksworld.com, datadriven.tv, Impact Quantum, and a new secret project that Andy and I have been working on for a while, datachannel.tv. Go check it out and hit me up if you want a discount code for the service. And with that, I will answer the question here. What is the best method to get into data science from an infrastructure background? I would say, as an infrastructure person, you have an advantage over traditional data scientists. So there's kind of this two worlds here, and I'll have to rely on Tim and Prashant to keep me honest on time, right? So if you kind of think about the data world, and I used to have a really cool thing. It was basically a slide deck for Synapse, but you basically had kind of traditional data DBAs, basically. I know that's not the proper term, but people who come from that kind of that era. And then you kind of had the data scientists, right? These folks here were all about SQL, right? Structure, schemas, right? Data scientists, they're all about, well, R, Python, right? The newfangled languages. Although Python's not really new, neither's R. They all didn't care about structure. Structureless or unstructured data, right? Schema on read, right? Don't make a schema until you need it, right? I would say from an infrastructure person, I mean, when these folks, data scientists are a curious lot, and I say this as one. They don't really, oddly enough, they don't know anything about infra, by and large. They don't know infra. They don't care to know. All they want to know is how many GPUs do I have at my hand? Can I get my hands on? So I would say, as someone who's familiar with infra like networking and things like that, I mean, I would say you have a good advantage there, because if you know the infra side of things and you learn kind of the math and the statistics, you already have an appreciation. DBAs kind of by nature, when things were on-prem, they already had kind of a pretty solid understanding of infra, right? If you were the person that got paged at 3 a.m, and yes, kids, pagers were a real thing. Go Google it. I mean, Google it with Bing. You had to know the info, right? You had to know, oh, I can't ping this. Or I remember the nightmare thing I had to deal with was TNS, which was Oracle's implementation of a name server, which I still have nightmares about that thing, and I'll use good language. But ultimately, that's kind of, you have that experience, right? You're probably not intimidated by pinging or doing networking type stuff like that. So you have that advantage. And I would say the best way to get started is, I mean, I could put a plug in for Data Channel TV. We kind of do that. But I mean, ultimately, the best way to get started is just getting familiar with things, the tools of the trade here, right? Jupyter notebooks, all of this stuff is either free or almost free. All of this stuff is actually open source. I mean, even Databricks is based on open source Spark. And there's a lot of good courses and stuff out there on LinkedIn Learning and Pluralsight and Data Channel. But I mean, I think that you already have an advantage because you know something about infrastructure, right? Data scientists, by and large, they tend to have come from academia, right? So they didn't. There's a lot of siloing in academia. So that kind of philosophy of siloing kind of does carry forward or has carried forward into the data scientist culture. And it wasn't that long ago where I spoke at a data science conference, and this gentleman who I think he went to Oxford. He was a professor at a local university in a tweed suit in July, right? This is all back when we can be in person. Said to me, sipping tea, like honest to God, said, "I'm so glad," because I told him my background and I'm and then he goes, "I'm so glad we have practitioners like you here at these conferences now." And I'm like, uh, was I insulted just now? Because there still is a heavy kind of academic thing in there. And if you look at kind of the real cutting edge, they're all academic papers. I recommend if you're really into that stuff, 2 Minute Papers is a YouTube channel. Fantastic, fantastic. He basically takes a research paper, and he goes through it and kind of analyzes it and shows you the demo and the code. Fantastic stuff. But I am close to time, and so I mean, I would say Microsoft Learn has a lot of good stuff there. If you can learn to kind of, be the infrastructure person that the data scientist will rely on, know, like, and trust, I think you'll be golden.
Well, Frank, thank you very much. You've upped your game since going
Oh,
off to
thank
another
you.
company. I will say that very well. Very good session and good Q and
Thank you.
A. So thank you for your time this morning, and thank you for your contribution to the community. We certainly appreciate it. I'm going to go ahead and stop the recording, and we are going to stand by until 11 o'clock. And Mr. John Tupitz is going to take over to talk about accelerating